We'll go ahead and get started in just a minute. For the record, my name is Aubrey. I teach geometry and a little bit of everything else. The general thing to be aware of is that I should be the opposite of a magician. If I am up here and wave my hands and you have no idea how I got to that answer, tell me, because I should not be losing you. We do go a little bit fast sometimes, but always should be clear. So do not just nod and smile if you do not understand. I will not be offended. So when I was here last time, I believe we were working on matrices. Does that sound familiar? All right, we had talked about labeling parts of a matrix, and we had talked about adding them, and we were just getting into multiplication. And we talked about, in order to multiply matrices, they have to have those same inner dimensions. And so if I have the matrix of 2 and -1, this is row by column, a 1 row by 2 column. If I have another matrix that is 3, 4, and -2, this is a 3 column by, or 3 row by 1 column. And if this is, no, I wanted to do that differently. This is 2 row by 1 column. So matrices are labeled by letter, and getting into multiplication, the inner dimensions have to match. And so A is a 1 by 2, B is 3 by 1. These inner dimensions don't match. And so AB is not possible to be matrix multiplied. Doesn't work. But the order is reversible. And so matrix B times A, B is 3 by 1, A is 1 by 2. The instant those match, now it's perfectly fine. That does work. And so matrix is one of the few multiplications that is not commutative. If you change the order, it changes your answer by a lot. The other thing to be aware of with this matrix multiplication is the insides have to match, but the outsides tell you how big your answer is going to be. Matrix BA is going to be 3 rows by 2 columns. And that would be our answer matrix. Each one of our elements comes from the row and column. So 3 by 2, this is first row, first column. The first row of B is 3 times the first column, 2. 3 times 2 is 6. That's where those individual elements of a matrix come from. If I need the second row, third column, I would go third row, second column. So I go to the third row and the second column. -2 times -1, +2. Third row, second column, +2. And so each element comes from those pieces of the matrix. That is working out with one number and one number. So the other part that I wanted to talk to you about is, what if I say A times C? And they're small enough, I'm going to copy them for reference. We have 2, -1 by C is 5, 0. And this is a 1 by 2 and 2 by 1. Insides match, multiplication is possible. What size is our answer going to be? The leftover at the outside. 1 by 1. It's going to be a single element matrix. And so for this is still first row, first column. That's the only thing we've got. So we have the entire first row by the entire first column. And so when you've got more than one thing in the row you're multiplying, or more than one thing in the column you're multiplying, you're going to multiply the matching pieces, which is why those inner dimensions have to work, and you just add them together. And so this ends up being 2 times 5 is 10, plus -1 times 0 is 0, and so our answer is 10. And so if you end up with more than one thing in the row you're multiplying or the column you're multiplying, you're going to be multiplying the matching pieces and then add them all up. So if you want to, in your Blue Prep Plus book, I believe it's on page 194 if they haven't switched this out, but we've got practice problems to go with this stuff. And that way you don't have to try and copy as much, because copying matrices is like the Achilles heel of matrices. They're vastly useful when you are dealing with a calculator or computer. They are really, really tedious if you try and do these by hand. And so they will try and keep the size limit down to 3 by 1 or 2 by 2 is the general pieces that they give you, just because anything bigger than that gets really out of control. So, purple book, not the ACT 36, just your standard Prep Plus big book, 194. You can bring it with me. Usually I'm better at holding it up. Yes.
Oh, we don't have the purple board. These.
Nope, I'll just have to put it on the board. How'd that happen? All right. So specifically, we're looking at the product of 1, 2, 3, and -1, -2, -3. So the first thing that I'm going to ask is, what are the dimensions of our answer? Well, I suppose the first question I should ask is this possible to be multiplied? Yes. What are the dimensions of our answer?
1 by 1.
Yeah. We have 1 by 3, 3 by 1. It's possible because these match, and these two tell us our answer is a 1 by 1 or a size 1 matrix. So right off the bat, A, B, and C are -14, 0, and 14. D and E are these giant 3 by 3 matrices. And so A, B, and C are still in contention. D and E are out of the running just because we know the nature of the problem. So next, we have -14, 0, and 14. So all we've got left is to multiply it out. -1 times 1 is -1. 2 times -2 is -2. 3 times -3 is -9. So which one's our answer? Oh, thank you. I'm concentration erroring. That does make it better. Yeah. Classic thing, if you make a concentration error and you don't see your answer, go back and check your intermediate math. And so this is frequently the level of multiplication that you'll see with these. They keep it pretty simple in order to save the time, because once again, you could probably get a perfect score on the ACT. The math is not stuff that you have not seen before. The question is, can you answer the 60 questions in 60 minutes? And so it's always the race against time. So, if we look at number 4, this asks us to evaluate 2x plus y plus 4z, and we are given 4, y, and 8 equals, multiplied by matrix x, y, and z is equal to 10. Yes?
Why is it 2, I think?
Hmm.
On the right hand, or on the right hand column.
4.
At least in the book it is on the column.
I've got 2x, y, 4z,
In the
4,
mid-
y,
on the right.
8. Thank you.
Sorry.
Again, glad you're following along in the book. So this one has both the matrix multiplication element and the solving element. So the first thing I want you to do is, can you multiply this out? Ignore 10 for a second, you'll use that later, but just can you multiply those two matrices? And again, what size will your answer be? 1 by 1. And so it always helps to know what you are aiming for, because it tells you, okay, I've got 1 row, 1 column, I'm multiplying my 1 row by my 1 column, multiply the matching pieces, and add them together. Asking you to do it on your own, give it your best shot. in cases where, particularly where you end up with the one element, and again, this element is the entirety of this thing. I find drawing the rainbow lines help me keep track of things. If we were multiplying it the other way, and x to z had been first, our answers would have been 3 by 3, and you would have ended up with x times 4, x times y, x times 8, and you would have all of those pieces. But especially for this one, we just have to multiply the pieces and add them together. So this is the matrix setup. What do we do next from here? Yeah.
I plugged in for x and z.
You plugged in for x and z. How do you mean by that?
Well, I know x and z both equal 2.
I don't think so. So what's going on here is a very classic ACT facet that you can not know individual variables, but you can know how those things relate to each other. For instance, back to geometry, we can know nothing about angle A and angle B. We don't know what they are, but we know that together A plus B equals 180, the straight line. Same thing is going on here. We have 4x plus 2y plus 8z equals 10. We don't know individually what x or y or z are, but we know that all three things together make 10. They ask us to find 2x plus y plus 4z. Again, we don't need to know the variables as individuals. We need to know all together they make this thing. And so what we're looking at is not what individually A and B are, but if I asked you for 2A plus 2B, what would it equal? A and B together makes 180s, so 2A's and 2B's make the entire circle, 360. Same situation here. We've got 4x right here, and we've got 2x up here, 2y and 1y, 8z and 4z. They're just showing off. They think they're being clever. This entire thing equals 10. Well, if we cut it in half, we get 2x. Cut it in half, we get 1y. Cut it in half, we get 4z. Cut it in half, we get 5. And so 2x plus y plus 4z is equal to 5. We can't know those pieces individually. One of them might be 0. But we can know all together that they keep that relationship. Upper limit of these type of problem. Probably one of the more difficult things they'll throw at you. Yes?
You can just plug in, I did it like a whole nother different way.
Okay.
Because I figured out, so if you plug in 2 for x and 2 for z, you get 8 plus 4 is 12, and then y equals negative 7, so it equals 5. And so I didn't know y at first, but plugging in both 2 for x and z, you can set up the equation y times 2 plus 24 equals 10.
I think by choosing numbers that the relationship works here, because it has that double effect, it would still work there. It would probably also work if you picked 0 for two of them. So here is 0, so y has to equal 5, right? Here is 0, y equals 5. And so that does work. It's not conceptually the answer they're working for, but it's a decent backdoor and I like it. And so picking numbers and just running with it is a great strategy, particularly if you're not feeling confident on another way to do it. So I like that. But notice it doesn't have to be 2. It will actually work with any numbers. All right. So last one is 3x 3 2w 2z plus 6 negative 2y negative 4. Did I flip-flop those? No, I did that right. And this equals 9, 4, 6, 10. Again, I do not have great confidence in my copying skills, so if I've copied something down, tell me now. And they ask us to find zy minus xw. So again, very common ACT technique. Rather than asking you to find these 4 answers, because then it'd be relatively easy to just guess and check, does that work in the equations given? They combine them all together into a single answer, because then you can't reverse engineer the problem. And so combining multiple answers into a single answer like this, there's nothing special about this. It just exists so that in the multiple choice they can ask for one number. So how would we set this up one thing at a time? How do we find x? Yes, focus in on the single element. This first row, first column, plus first row, first column, equals first row, first column. There are 4 different equations going on right here, and you just have to work with each of them. So 3x plus 6 equals 9. Subtract 6 from both sides, divide both sides by 3, x equals 1. Same thing, 3, negative 2y, 4. Subtract 3 from both sides is 1, divide by negative 2 equals negative 1/2. Y equals negative 1/2. 2w, negative 4, 6. 2w minus 4 equals 6. Add 4 to both sides, 2w equals 10. Divide both sides by 2, w equals 5. Agree, disagree? I'm losing anybody? So w equals 5. And then 2z minus 6 equals 10. 2z equals 16. Z equals 8. 8 times a negative 1/2 will equal negative 4. Minus 1 times 5 is minus 5. Altogether we have negative 9. So again, multiple problems. None of them are hard on their own. They just like to take all those answers and shake them up so that there's no way to solve this using guess and check. But once you know the individual elements equal the other element, you are good with matrices. Okay. Go ahead and look at the book for matrices. It is, what page is this on? It's been a while. Logs. Page 12. So the last thing in this booklet is the determinant of the matrix. And it's got its own special symbol. It looks kind of like the absolute value. I think they just ran out of notation, but that's not an absolute value sign. It means determinant. But it's in the book to be aware of it. But all of the tests that I have taken in preparation for this, looking through many, many tests, every test I've ever seen always gives that formula. And so I wouldn't put a whole lot of effort into memorizing that, but just to be aware of it. Determinants have to be square matrices, a 2x2, a 3x3, a 4x4, and they're only going to ask you about the 2x2 because the process for 3x3 is really kind of tedious. And so in your classes, you may end up doing it just to understand the process. Frequently, again, it's done by calculator or computer if we actually want to make use of it. But just so that you are aware of what's going on, we have the elements A, B, C, D. And for the determinant of the matrix, it's taking this diagonal and multiplying it together, A times D, and subtracting the other direct diagonal, B times C. And the only thing that I've seen with the determinant is frequently just find the determinant and then they give you the formula. And so it falls in the category of, this is not a difficult problem. This is basic algebra, plug in the numbers and get an answer. But it's designed in a way to make it look scary or intimidating. There are a fair number of ACT problems that if you know it, it's easy. If you don't know it, it makes people feel intimidated. I don't like it about the ACT, but I swear the test exists to make people feel scared. To find out, do you feel confident about math or not? Not do you know it or not, but do you feel confident about it? And I think there's an element of usefulness to that because the confidence with math is what allows you to call it up on a moment's notice, not just, hey, I learned it once upon a time for the test, but now it's gone out of my brain. So I can respect that, but at the same time, sometimes, again, I just think they're showing off. So again, that page has the matrices on it. Are there anything that you would like to go over in more detail before we move on? So for the rest of today, we're going to talk about the page before that on 11. It says conic sections. You know the conic section parabola really well, but we're going to specifically talk about circles and ellipses. So this x minus h squared plus y minus k squared is equal to r squared. Have you dealt with that before? Okay, so this should be review. That is good. I'm trying to find. So I am big on understanding the parent functions of all of the equations. So this is the circle graph. With the parabola, we have that one. With the ellipse, we're going to have very, very similar. It just adds in a new wrinkle of the number at the bottom. But the basic categories are we changing it before the operation happens? And so this H, 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 all of those are changing X before the square happens. And so they move it horizontally because X is the horizontal direction. Here, we are changing Y. This one, it happens at the end, but you could write it as Y minus K equals A X minus H squared. And so this K again is changing the Y. Changing the Y changes the graph vertically. And so all of these different shapes, again, this is a circle, this is a parabola, this is an ellipse, but they're all following the same patterns. And so the more you get comfortable with generalizing those patterns, the easier it gets to work with all of them. So, specifically with circles, what does the R stand for?
Radius.
It's the radius. It's how much you vary. And in particular, this H and K is going to be the center of our circle. Horizontal H, vertical K. And this radius is about the trigonometry of a circle. You're talking about the hypotenuse is always that radius, and it's just how far over, how far up it's changing. But specifically, when X is 0, when there's no horizontal change at all, you're going to have the radius above or the radius below. When Y is 0 or no vertical change, we have the radius and the radius. And so these are the 4 points, if you ever have to graph a circle, that you kind of want to put as reference points. And then you just draw in your circle from there. This one, a circle is just a specialized ellipse. It happens to be an ellipse that's the same side to side, top and bottom. And so this could also be written as R squared, and 1. Circle is just a specialized ellipse. And so again, with this A and B, this A is about how far horizontally it's wobbling. B is about how far vertically it's wobbling. And so that is the very much general description of what's going on. And since you say you've seen these before, I'm not going to spend a whole lot of time on that before we just dive into problems. So, this one's kind of fun. It tells us that we have an ellipse, a circle, and an ellipse. I think I've drawn that. No, sorry, I did that backwards. It's supposed to be 2 circles and an ellipse. got an ellipse, and we have the inner circle and the outer circle. So we've got two circles with an ellipse in the middle, and it says shown below in the standard XY coordinate plane are two circles and one ellipse, each centered at 0, 0, the origin. The larger circle has an equation of x squared plus y squared equals 25. The smaller circle has the equation of x squared plus y squared equals 4. And the question is, which is the, write the equation for the ellipse that is intersecting each of these circles at the respective 2 points. So what would the equation of the ellipse be? So first question is, what's h and k for our ellipse equation?
0.
0, so we don't have to worry about that. All we need is x squared plus y squared. What is it going to equal? 1, because it's an ellipse. All we are looking for are the a squared and b squared. So a goes with x. On our ellipse, what is our wobble from the center? 5. And again, it's squared, so we are back to the 25 number. For our y, our wobble, or change in both directions, is our smaller circle, or our y direction up and down. And so this is the 4. So again, if you understand conceptually what's going on with a circle and what's going on with an ellipse, not a terrible problem, but it is kind of weird. It's asked in a way that honestly I've never seen other than on an ACT test. And so it's digging into this conceptual stuff of where do these numbers come from, and then using them to combine into an ellipse equation. I'm going to erase this problem, but leave the equations for your reference. Occasionally, these will get a lot easier. I didn't write any down for you, but just as an example, they'll ask for the equation of a circle centered at -3, 5 with radius of 7. And so sometimes it will be that straightforward. So I don't want you to freak out about circle equations and think that they're all as tricky as what I'm throwing at you, but sometimes they're going to be more like this. And honestly, 75% chance it's probably an easier one. Usually one sort of circle problem on each test. Sometimes it's easy, sometimes it's more tricky, but just to double check, you can do that one? Okay. I don't want to, again, don't want to be too hand wavy, but I'm assuming you can do that. So the question that we're going to do next says, graphed in the same standard XY coordinate plane, are a circle and a parabola. The circle has a radius of 3. And it is centered at 0, 0 again. In general with circles, unless they are just asking you to write the equation, for most of the conceptual stuff they go back to centered at 0, 0. And so anytime they combine it with something else, frequently they go back to the origin. The parabola has a vertex. This is our circle. I'm just shorthanding. Our parabola has a vertex at -3, -2. And it passes through I want to make sure I copy this right, -2, -1. And the question is, the circle and the parabola intersect at how many points, or how many times will the parabola cross the circle? I want the number of intersections. I'll give you 3 minutes to work on this one. So, if you got a great answer, great. If not, before I start explaining, I want you to give a ballpark answer. What would your gut instinct say? Because guessing is a valid way to tackle these. But, centered at 0, 0, we are going to be at -3, +3, +3, -3. Those are the reference points. We don't know exactly the points in the middle, but we know those reference points. Now, our vertex is at -3, -2. It's somewhere down here. And since, again, they tell us vertex, this is the axis of symmetry, we're going to be looking like this. And so here are our 2 crossing points. It doesn't have to be a beautiful drawing. Important thing, it says that it passes through -2, -1, and I probably should have drawn that better. But without that piece of information, what would the other possible answer have been?
1 or 0.
I actually like both. For the 1, we could have had a tangent point. That's one way to get 1. And with 0, all we have to do is give it a much steeper rate of change. So all of those are possible. That passes through is required in order to be able to answer that question. So good to be aware of it. All right. This may be the last one. We may have time for one more. We will see how it goes. In general, your confidence level tells me that you've been working on these problems relatively recently, or your teacher did a really good job at teaching them. So one of the two. So again, standard XY coordinate plane, circle centered at 1, 3. So we have a non-origin centered circle. Passes through the point 4, 7. Do as I say, not as I write. There. So, and making sure I. So, what would the equation of this circle be? Couple people still working here, so we'll take another half minute or so. So, in order to write a equation, we need two pieces of information. First one, they gave to us. Where is the center of the circle? So, x, looking at the x coordinate, this would be x minus 1, y minus 3. Remember, if it had been a negative number, you end up with the minus minus and it turns into plus. Be confident with that situation. But the other piece we need to know is, what is the radius of this circle? So, I am not big on the distance formula. Does anybody still love the distance formula? I have it memorized. Okay, go back to Pythagorean theorem. Way easier. Distance formula is just about the change in x, or how much you've moved horizontally. The change in y, how much you've moved vertically. From 1 to 4, I've moved horizontally 3 units. from 3 to 7, I've changed vertically 4 units. Have I given you my spiel on 3, 4, 5 yet? Okay. 3, 4, 5 is guaranteed to be on the ACT. It has been on every single test I have taken so far. It's called a Pythagorean triple. It's 3 nice pretty numbers that make a right angle, and they love it. It is going to show up somewhere on every single test you have. If you have 3 and 4 are the legs of a right triangle, the diagonal hypotenuse is always 5. If you have to run it through the Pythagorean theorem, you'll get that answer, but save yourself some time. 3, 4, 5 always shows up on every single test. It's always there. So if we have a change of 3 and a change of 4, our radius diagonal is 5, so this would be 5 squared. And that's it. So don't try and do the distance formula as a memorization thing. Go back to a triangle, the horizontal change, the vertical change, and if you get 3 and 4, 5 is always the hypotenuse. Always, always, always. All right, we will go ahead and pack up. Especially for people online, is there anything I can clarify before you go?